Alright, hi solid chemistry students. This video is for our lab, the experimental determination of the molar mass of a monoprotic acid. And together let's just review our pre-lab here. The titrant we're using, remember that's what goes in our burette. Our titrant in this case is our sodium hydroxide, NaOH. Prior to filling the burette, guess what? I've already rinsed it with some of that NaOH. I poured a little in, I let it run through, add a little more, let it run through, and then finally I fill it up to the 0,0 mark. I've put in 15 milliliters of our acid. The molarity of the NaOH is 0.50 molar. The indicator we're using is phenolphthalein. I've added it to the flask. I've put the NaOH into our burette. I've already put the acid into the flask. And I know I'm going to want to stop this titration when that very faint light pink color sticks around. And what we're trying to figure out is the molar mass of this acid. So again, we're seeing another use of titrations, where not only can we get something like molarity, but we can also get something like the molar mass of an acid. So this is my third trial, and I'm going to put a picture in here in the video in a couple of seconds to have you guess the starting volume. But let's go ahead and titrate this bad boy. And again, I'm going to start it off pretty fast because this is my third trial, and I know about how much of my base from the burette I'm going to add. Remember, what goes in the burette is the titrant. It is our solution with a known concentration. I'll just swirl it a little bit. Again, just kind of swirl it, swirl it. Okay, so it's staying around a little bit longer. Notice again that pink color from the indicator. It's just recognizing the base as it's being added, as soon as it's being added. And then we swirl it. We make sure that the base reacts. Okay. And notice I've slowed down now because I know I must be getting closer and closer to my equivalence point as that pink color is staying a little bit longer each time I add a little base. So you notice it's staying a little bit more, but as we swirl, we make sure that the base in the burette is reacting with the acid. Oh, getting really close now. Getting real close. Sorry about that, cutting off the camera. There we go. Oh, real close, a couple drops. Ooh, super close again. You can't see real, I'm sorry. There we go. Look at that stick around. Almost. Oh, okay. Looks like that light pink color is staying. Maybe a tad dark, maybe a tad too much there. But that's okay. That is what it would look like. All right, so again, I'm going to put in a picture at this point as I take a look at the reading. And you'll have to read the final volume off of the picture in the Edpuzzle video. I'm going to do the same thing for trial 2. I'm going to put in 2 pictures. You're going to have to read the start and end value. But what I want to do in this video is also kind of show you our calculations. So let's do that. I'm going to pause and rearrange so you can see some writing I'm going to do. All right. So again, you can see my trial 1 data there. For each trial, we know that our concentration of the base is 0.50 molar. As you can see, my start value was 1.40 milliliters. My ending value was 16.00 milliliters. So the volume that I used total for trial 1 was 14.60 milliliters. And let me just go ahead and show you again, everyone, for each trial, our molarity of the base was 0.50 molar. Now let's try some calculations. Again, I did trial 3 for you earlier in the video, and then after that part, you saw pictures of your trial 2 volumes. Let's look at some of these calculations. Okay. So I might have to adjust my camera here again. Okay, so we kind of have it there. So, first calculation is to calculate the moles of acid that were titrated in each trial. Although we know the volume of the acid, we want to leave that unknown because MA times VA is the same thing as moles of acid. And maybe I should take a step back here. Hopefully students remember to calculate our molar mass. What we've done before this year is that grams over moles calculation. If you kind of skip down to number 2, you'll see that we have grams of acid. And so what we need to find is moles of acid. So we're going to use this formula MEV equals MEV to figure out moles of acid because, again, M times V is moles. It's a rearrangement of our molarity formula. So you can see I've plugged everything in. MAVA is our unknown, that's moles. Our equivalency of the acid is 1. It's monoprotic, that stays the same. And then we set that equal to our molarity of the base. For each trial, it's 0.50 molar. The equivalency of the base is always 1. It's sodium hydroxide. And then VB, that's again, we got to subtract to get that. That's our volume of the base in each trial. So I'm going to multiply what's on the right, 0.50 times 1 times N. Be careful. I made a little mistake when I first wrote this out. We want the volume in liters. Volume's got to be in liters. So 0.5 times 1 times 0.01460. Remember, that was 14.60 milliliters. And I get from my moles of acid, I get 0.0073, and I'm going to just rewrite that unit there. Should have 2 sig figs from the concentration of our base. So that's 0.0073. Just 0.5 times 1 times 0.01460. Remember, your volume of base needs to be in liters. Divide by 1, that doesn't change anything. We get moles of acid. So now we can go down to the second part. Where now what we want to do in step number 2 is to calculate the experimental molar mass. And remember, we do that by molar mass equals grams over moles. And it tells you that our grams are always 0.760 grams. For each trial, grams will stay the same. And then we want to plug in the moles we found from up top, 0.0073. So again, for each trial, you use the moles that you calculate. So 0.76 divided by 0.0073. And we get a molar mass of, it only says 2 sig figs, but let's just carry more here. Let's carry like 2 decimal places because it's a molar mass. I got 104.11 grams per mole. So this is what you have to do for those other trials. Again, you're going to have to record those volumes from the pictures into your data table on page 25, and then do these same calculations, and then finally do the, that is a terrible answer. Wow, that was really shoddy on my part as I look at my answer here. The accepted value was 60.1. That was not good, but that's what I got. Oh well. Anyway, do the rest for your calculations. Good luck, folks.